And welcome to Module 6, Lesson 15, using unique triangles to solve real-world and mathematical problems. Okay, so unlike the two lessons prior to this, 13 and 14, where we just used different diagrams and relationships and techniques to uncover whether triangles were identical, we are going to actually pose another challenge to you, where you're going to be asked to determine whether triangles are identical, like we have been, and then you're going to need to show how this information can lead to further conclusions about the diagram. Okay, such as maybe showing why a given point must be the midpoint of a segment based on your determination of identical triangles. Okay, so hence the idea of real world problems. Okay, and also some mathematical problems as well. All right, so without further ado, let's see how you do. Okay, here example 1, a triangular fence with two equal angles, angle S and angle T, there and there, is used to enclose some sheep. A fence is constructed inside the triangle that exactly cuts the other angle into two equal angles. Okay, which are, let's see, SRW, zoomy brown, okay, and then TRW, zoomy doomy doom, okay. All right, so it cuts those triangle exactly cuts the other angle into two equal angles. All right, so we know that these two right here are equal. Okay, equal right there. Your mission here is to show that the gates represented by SW and WT are the same width. Okay, so you're going to try to show, or you're going to use what you know to show that that right there is equal to that right there. Okay, so SW, S to W, and then W to T. Okay, so you need to show that these two gates are the same width using what you know here, or what's been given to you here. Okay, so good luck with that. Give it a whirl and find your correspondence and use what you know, and let me know what you find out. Okay, well, if you look at this, and you look at this closely, you'll recognize that we have here, again, we have two triangles, okay, and entirely two triangles here, SRW, okay, I should probably do something in different colors, so SRW, which is right here, okay, and then let's get a purple or something, and then we have TRW right there. Okay, so what we do know about them is that we have been told already that we have some equal, we have two, and those angles are the same, these angles are the same, okay, therefore we have our two angles, okay, and what we also know we have, okay, because this has been split right down the middle here, we are sharing a side, okay, so these sides here are also going to be the same. So we have two angles and a side condition, and that side happens to be opposite of an included angle, which is right there, okay? An angle, opposite an angle, there and there, okay? The same. So two angles and the side, opposite given angle, okay? So there we go. And we have met those conditions. And because we have met those conditions, we know that these are identical triangles. And if they are identical, everything about them has to be identical. Therefore, the gates here are going to have the same width. This one here, SW, and then this one here, WT. Okay? Okay, here, example 2 here. In triangle ABC, AC equals BC, okay? AC equals BC, right? John says that the triangle correspondence of triangle ABC and triangle BAC, which is over here, this side, here's BAC, okay, matches two sides and the included angle and shows that angle A equals angle B. Okay, angle A equals angle B. This is what John is saying. Okay, is John correct? Okay, so go ahead and take a look at it. It's always fun to correct someone's work and decide whether they are using good logic or not, especially when you don't really know this person. So go ahead and give me your summary of what you think is going on here and whether John is correct or not. Okay, well, just the fact that John tells us that the triangle has its correspondence here of ABC is corresponds to BAC, so that, okay, ABC is the same as BAC. All right, if that corresponds right there, then that means that everything is the same. All dimensions are the same, all measurements. So that's going to be that, and all of these are going to be, I should probably do it this way. Oh, well, yeah, whatever. Anyway, those are all going to be, everything's going to be identically matched, okay? And because it is, that means these are identical. And if these two are identical, that means that his claim that angle A equals angle B would be correct. So in this case, we weren't able to mark John down. We would have to admit that he was correct. And again, it all boils down to that correspondence there. Okay, exercises 1 through 4. We'll take you through a few quote-unquote real-world problems and mathematical problems. So why don't you go ahead and do those. If you stumble at all, you know you can re-look at them when we look at them together. Okay, so go ahead and do those, and that is actually going to be the end of this. That will conclude this lesson and this topic. And what you'll have next will be your mid-module assessment, okay? So, yeah, go ahead and do these exercises 1 through 4 and come back and we'll look at them all together. Okay, well, this number 1 here might have been a little bit confusing to you. I know it was to me, first blush here. So, again, Mary puts the center of her compass at the vertex O, okay? So here's O, okay, right here, okay, the vertex O of the angle, and locates points A and B, okay? So what that looks like here when you use your compass to do that is you take your compass here, and I have my compass, centered on O right there, and then I just take it, put my pencil in. Now you can see I've done A already. I'm putting my pencil in the little, I guess which slot it was here. I think it was this little notch right here. In that notch, and then you put the pencil in the notch, and then you go back and forth with it. You just take it, go like that, and that makes that little mark like this. It's a little more pronounced, a little more, looks a little bit more arc-like on there, but no, I guess it looks pretty much the same. Anyway, that's how she made these marks right here, and that might have been confusing to you. That's how she made those marks. I mean, a compass is a really good way to actually help with your measurements, making the little intersections right there where those points are going to be. Okay, yeah. So she found the sides of the angle. Okay. Next, she centers her compass at each of A and B to locate point C. Okay. So when she does that, I guess I don't have a picture of that. I don't think. Yeah, okay, yeah. So what she does here, yeah. So she goes ahead and she's going to put, I didn't put a picture of putting the compass there, but she has a compass here now. She centered the compass just in this same fashion here, but going this way, and then she's made her little mark there. Does the same centering here, and makes the mark there, and then she has this one right here, this line, this point right here. So the point is right there. So all the points are right where the intersections are, there, intersection. Okay, so all of those are the points. Now what is she going to do with these points? Well, she can go ahead and she can just draw lines. So line and line. And what she knows, okay, is, I guess we'll just go ahead and finish it up here. So finally she constructs, so could explain why angle BOC is equal to AOC. Okay, and this is why we want to know. So this BOC here that she's created, why is that the same as AOC? All right. Well, she's done several things. She's made sure that she has the sides equal. Okay, these two sides are equal. She's already done that. Okay, she knows that angle O, of course, is going to be is equal. She's splitting it in half. Okay, so she's centered. She has this point here. Point C has been centered. Okay, and because it's centered, then we know that both sides here are going to be equal, because we're going to have equal sides there. These are both equal here. Okay, so we have our two sides already that are equal, and because we're going to split that right there. So we have pairs of sides that are equal, and then because we've split that in half, we have equal angles as well. Okay, so we know that we have this correspondence, and also we have a three-side condition as well, because this is a shared side right there. So if we have this three-side, this is probably even a better way to figure this out. We have the three-side condition met, okay, because she's made sure with her compass to center and make sure everything is equal. We have the three-side condition met. Therefore, if the three-side condition is met, then they are identical triangles, and therefore all the angles would also be equal. Okay. All right, so let's go ahead and give number 2. Let's look at number 2. Oops, let me do that. Number 2. So we have quadrilateral ACBD. Okay, is a model of a kite. Okay, is a model of a kite. ABCD there. The diagonals AB and CD, okay, represent the sticks that help keep the kite rigid. Okay, AB, CD. And those are right here, AB, CD. That makes sense. Those are the sticks that help keep the kite rigid. So John says that ACD, okay, ACD, angle ACD, okay, equals angle BCD. I should probably do that in a different color as well. So BCD. He's saying that those two angles are equal. Can you use identical triangles to show that John is correct? Okay, so again, he is saying these angles right here are equal. That one in there and that one in there. All right, he's saying they are equal. Can you use identical triangles to show that John is correct? So give that one a whirl. Let's just take a look at it. Okay, and again, this is really very similar to the one we just did up there, 1, okay? Well, we can see what we've been given. If you look at the diagram, which I wasn't originally looking at it, paying much attention to this, but the diagram, because it is a model, okay? We do have sides here. Again, we're looking at these two separate triangles. We're trying to separate these out here. We're looking at, just do this here. We're looking at this one here, ACD, okay, that triangle. And then we have BCD over there, okay? And we can see we have side, side, and then, of course, the third side right here, because they both share that side. Therefore, we have a three-side condition, which was the same as above. And if we have a three-side condition, then we have identical triangles. And if we have identical triangles, everything about that triangle is going to, or two triangles are going to be identical, okay? And our correspondence, triangle-wise, okay, is ACD, triangle ACD corresponds to triangle BCD, okay? And therefore, we have angle ACD indeed equals angle BCD, which is what John had claimed, and therefore John is correct. Yes, he is. John is correct. Yes, indeed. Okay, in part B, Jill says that the two sticks are perpendicular to each other. Okay, so use the fact that angle ACD equals angle BCD and what you know about identical triangles to show angle AEC equals 90 degrees. And that angle AEC, let's go ahead and take a look at that. Angle AEC right there. Okay, so Jill is making the claim that these are 90-degree angles. Okay, well, let's take a look. Yeah, so this one can get a little bit complicated, I think. But anyway, here I have drawn out, redrawn the kite diagram, and just noted the angle that we're interested in, because Jill says that they're perpendicular, and we are trying to find out if they are perpendicular, if those two lines are perpendicular, then the two sticks, anyway, are perpendicular. And again, those sticks are, I don't think I have to really show you again, but they are this and this, of course. Those two sticks are saying they're perpendicular. And if they are, then we're looking at the angles being 90 degrees in one of those angles. This one right here, AED or AD. Oh, look at AEC. I'm sorry, I was going down the wrong way there. I'm going to go AEC. We're trying to find out if these are 90 degrees in here. Okay, this right here, if this is 90 degrees, trying to prove that. So here's what we know. We know that AC equals BC. Okay, we're given that. Okay, we can see that here and here. We also know that angle ACD equals angle BCD. Okay, so we have that right there. We know that those are equal. Okay, and we also know that triangle ACE and triangle BCE share a common side. Okay, share a common side. So we have these two triangles right here, and you can see that they are sharing a common side. So they have, there's their common side right there. So those we have two angles, two sides that are common. Okay, we have two sides that are equal, and we have an included angle condition. Okay, we have included angle condition. We can conclude that angle AEC is equal to angle BEC. Okay, angle BEC. And since both angles are adjacent to each other, right next to each other on a straight line, okay, right here on this straight line, these two triangles right here, ACE and BCE, okay, they are adjacent to each other on a straight line. That means, remember, angles on a line equal up to 180 degrees. Okay, and because we know that these two triangles are identical based on our knowledge over here, we if they're going to equal 180, they both need to be 90 degrees, okay? So they are both 90 degrees right there. So Jill's claim that they are perpendicular would be correct, because we have just proven or just shown that angle AEC is 90 degrees, okay? And that's, by you doing that, we have helped her prove her point that these sticks are perpendicular. Okay, so just finishing up this one here. It says, John says that Jill's triangle correspondence that shows the sticks are perpendicular to each other also shows that the sticks cross at the midpoint of the horizontal stick. Is John correct? Explain. Okay, well, this, yeah, well, I'm not sure if it's the sticks that the perpendicular sticks that do this. Maybe it does, but since we've established that triangle ACE and triangle BCE are adjacent to each other, okay, right next to each other there, adjacent. We know that AE equals BE, okay, right here. We have, I need a new, man, I got colors here. Yeah, we have AE right here, and we have BE. We know they're equal, okay, we know that they are equal. So if they are equal, that means that E is indeed the middle point, okay, middle point. So, yeah, John is correct, because they do cross right there at that middle point, okay? So, yeah, John's correct there. Okay, so now we have number 3. So here, number 3, in triangle ABC, angle A equals angle B. Jill says that the triangle correspondence, triangle ABC corresponds to triangle BAC, matches two sides and the included angle, and shows that AC equals BC. Is Jill correct? Well, let's take a look at that. Yeah, so but Jill's pretty much given us all we need here. Okay, again, she's given us, she's told us about these two angles being equal, okay? But she's also given us that triangle correspondence. So she's saying that ABC, okay, corresponds to BAC. Therefore, if that is the case, then we have identical triangles here, okay? Identical triangles. And now, now she's saying it's the two sides and the included angle, and matches the two sides and included angle. So we have that angle and angle right there, okay? So we know if they are identical, if these are identical, then everything about them is going to be identical, okay? Which would mean that, and we're looking at this correspondence here. So AC equals BC, so we'll be moving the same way, this way and then that way, okay? Here's our AC, okay? And then here we're moving here and BC right there. So they indeed would be equal right there. And Jill is correct. Yes, she is correct, because we've established identical triangles, and the correspondence, the way it is, makes us know that these two sides are indeed equal. Okay. All right, so here's, that gets us to number 4, okay? Now we have right triangular corner flags are used to mark a soccer field. The vinyl flags have a base of 40 centimeters, okay, and a height of 14 centimeters. Mary says that 2 flags can be obtained by cutting a rectangle that is 40 centimeters by 14 centimeters on the diagonal. will that create two identical flags? Okay, and explain. All right. Well, let's take a look at this. Okay, well, as we know, we have a rectangle. Okay, we have a rectangle here, and it is 40 by 14, 40 centimeters by 14 centimeters. All right, which means then we have 40 centimeters here as well, and then 14 centimeters here as well. Okay, so we have these two flags that we'd make from this rectangle here are already going to have two sides, equal sides, and then two pairs of equal sides there. Okay, and being a rectangle as well, we know that these are 90-degree angles. Okay, all 90-degree angles. Therefore, we have two sides, and an included angle. Okay, that 90-degree angle is included. All right. Therefore, we do indeed have two identical flags. Yes, we do. And again, I've just explained why. All right. And and then B here says Will measures the two non-right angles on a flag and adds the measurements together. Can you explain, without measuring the angles, why his answer is 90 degrees? Well, that's a fun one. Okay. Yeah, well, as you see, as our whole rectangle up here, of course, we know that each angle is 90 degrees. Therefore, we have 360 degrees total. Okay, in the entire triangle. Okay, the non-right angles here. So if we take this and this. Okay, here's our flag. Here's our 90 degrees here. Okay, our 90 degrees. Now this triangle right here, of course, we know has to be 180 degrees total. Okay, 180 degrees total. Now, to be 180 degrees, and we already have 90 degrees here. You probably know this already. These two non-right angles need to equal up to 90 degrees, okay? They're 90 degrees because 180 minus 90 equals 90, okay? And that's what's left over. So therefore, this plus this need to equal 90 degrees, okay? All right, and that's the way it will always be. All righty? So here we are, our lesson summary. We are here at the end of lesson 15, topic B, module 6. 12 lessons to go in this module. Will we make it? Will I make it? Not so sure. Anyway, here's a summary to this lesson. In deciding whether two triangles are identical, examine the structure of the diagram of the two triangles to look for a relationship that might reveal information about corresponding parts of the triangles. And we've said that already in prior lessons. This information may determine whether parts of the triangle satisfy a particular condition, which might determine their identical natures. Be sure to identify and label all known measurements, okay? If you're not doing that now, really be very, very sure. All known measurements. Everything you know. It's always a great idea to start with what you know, okay? Begin with what you know, all right? And then you will have a much easier task ahead of you, okay? And then determine if any other measurements can be established based on the knowledge of geometric relationships. We just did that and applied that to quote-unquote real world experiences, all right? And mathematical problems as well. Anyway, here we are. We're at the end here, and it is time for you to finish up, complete your problem sets, and then move on to the mid-module assessment, which you could do next week, I guess, or whenever. I'm not sure when you're doing this. I'm kind of behind. I don't know if any of you are on task or on schedule, but Yeah, whenever you get to it, you get to it. Okay, if you have any problems, please don't hesitate to call or email. You don't have many days left, only about 2 more weeks of school as I record this in this May 14th, 2015. Okay, well, good luck, and again, please don't hesitate to call.